If the fabric of space is constantly expanding, it raises a challenging question: how can we meaningfully talk about the location of anything in the universe? After all, if distances are always changing, wouldn't that make positions meaningless? The answer is that while there's no fixed, universal reference point in space, astronomers use relative measurements and special coordinate systems to keep track of where things are. First, it's important to understand that in an expanding universe, there's no central anchor point or cosmic origin inside the space we inhabit. Every point in the universe moves away from every other point as space stretches. This means there's no absolute center we can measure from. Positions only make sense relative to other objects. One of the most useful tools for creating a frame of reference is the cosmic microwave background radiation. This faint glow left over from the Big Bang is remarkably uniform across the sky, but tiny variations in it let us determine our motion relative to this ancient light. While it's not a physical location, it serves as a kind of universal backdrop, a reference frame for cosmic measurements. Astronomers also use redshift to measure how far away an object is and how fast it's receding from us due to expansion. Redshift doesn't give a fixed position in the sense of GPS coordinates, but it tells us where an object is along the timeline of cosmic expansion, which can then be translated into distance within a chosen model of the universe. Another approach is to use comoving coordinates. In this system, the coordinates of galaxies stay fixed even as the distances between them grow. Think of it like marking points on a stretchy rubber sheet. The marks keep the same positions relative to each other, even though the sheet is expanding. This allows cosmologists to describe the large-scale structure of the universe without constantly updating every position as expansion happens. What all of this means is that location in the universe is always relative, and it depends on the framework you choose. On small scales, like within the solar system, we can define positions with high precision using Newtonian mechanics because expansion has no measurable effect locally. On the largest scales, we define positions in ways that account for the dynamic nature of space itself. So while there's no fixed cosmic address that works for all time, we can still locate objects in a consistent way, by defining reference points, using relative measurements, and choosing coordinates that fit the expanding universe we live in. In an ever-changing cosmos, location is a matter of context, not absolutes.